So about, I don't know, 6 months ago at least, I picked up this Macintosh Powerbook 165. This particular unit suffered the infamous capacitor failure in the passive matrix LCD display, which caused the the contrast to kind of shift from one extreme to the other, kind of on its own. It wouldn't maintain the contrast level that you set it at. And in more extreme cases, the display may be completely blank. Well, I began repairing this machine, and I started working on a video of this, and I screwed up. I accidentally overheated the LCD panel with a hot air gun, and I gave up on the whole project and just sort of abandoned it. Well, just today, one of my viewers shipped me an entire 165 top case and display assembly. And I need to figure out who exactly that was. I have a name, but I'm not sure what the YouTube username is. But I'll have to thank him later. I need to send him some money. But anyway, so I got this entire top case, and we're going to see if this even works. I'm planning on recapping this display the correct way, and you know, surface mount caps are very tricky sometimes to replace, and I know how to do it now, but when I first started doing it, I screwed up and destroyed a perfectly working display. But anyway, I still have the old backlight assembly from the one that came with this machine, just in case I need it. And I've got a complete clamshell assembly, which was in perfect condition, so I saved it. Generally, they crack here, 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 and here. And this one doesn't show any signs of stress cracks of any kind, so this is definitely worth saving. The top case that came with this machine has no yellowing or discoloration of any kind, and that we're going to preserve. But first we need to see if this display works. So I'm going to mount this top case on. Oh yes, and this laptop has a good working quantum drive. This is the original drive as far as I know. So I'm going to put this together and we're going to see if it fires up. Yeah, just sort of sitting there, but let's see what happens. Oops. It's not lined up. Let's try that again. Good enough. Okay. Oops. Here we go. Alright. It's not looking good. Oh, 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 there it goes. Hear that hard drive kick in. Got some contrast. I'm going to adjust it manually. So it looks like this display lights up. It has pretty good contrast. You got to remember, if you're not familiar with how a passive matrix display looks, yeah, it's these were bad when they were new. This is about what it would look like when it was new. I mean, you have a lot of ghosting and shadowing that is perfectly normal on these. What is not normal on these is actually, this is starting to look pretty bad. We have a lot of shading here. This looks to be a little excessive. You got a lot of these lines. That's not abnormal, but it's not. I think this is a little excessive for one of these. It definitely could benefit from a recap, and that's what we're going to do now. So we're going to recap this display and see if we can't get it to look any better. I've owned these machines when they were almost new, and I can tell you that this one isn't that far off. But I have a complete set of caps, so I'm going to use them. Do some preventative maintenance, if nothing else. What happens is the caps eventually, as they age, they start to leak electrolyte, and they start to drift in value. They start to develop high ESR, equivalent series resistance, and at that point, it's pretty much, you just have to replace them. So that's what we're going to do. We're going to take this display down and hopefully bring it back to life. So I'm going to shut this baby down. The other thing I'm going to do is I have a new CMOS battery, and that goes right here in the top case on this interconnect board. We're going to replace that. I have that already on hand, and see what we can do. Okay, so this is the donor display back cover, and let's take a look at the problem areas. Now, you saw the one that I have. I'm going to do a quick look at this one. So look at these. So this one has the beginning stages of imminent failure. These will fail. There's a crack here. There's a couple of cracks on this one. I see one there at least one. This one's in trouble over here. That's getting ready to pop. And then this one is also cracking here. This one was produced in '91, is also revision A, and has no signs of any cracks of any kind. Disassemble the display to get these caps replaced. Now let's check my cap inventory. Let's see what I got. I've got plenty of these 3.3 volt, 3.3 microfarad 50 volts, 3.3, 35. Yeah, so these are those little ones right there. Okay, they're a little bit physically larger, but they'll work. And I need 1, 2, 3, 4, 5, 6, 7, 8, 9, and I have plenty of those. 3.3, 35 volt. Now, these are the bigger ones. These are the 100 microfarad 35 volt, and the original ones were 6 volt. 22, 35, 100. Oh, wait a minute. And then I got some of these 22 35s. That's going to replace these here. There's one there. So yeah, one of each, and then I got all these. So let's get this show on the road. To get this apart, we've got to pull the backlight cable. Actually, that can stay where it was. I didn't need to do that. I'm going to need my pliers. We're going to shut this fan off. We don't want too much air movement because we don't want too much dust contamination. If we can help it, we're going to undo these little latches here. The old display I got rid of because it was beyond repair. So sadly it had to go. I think I successfully replaced one cap on that one before I gave up on it. I melted the sucker. Not one of my proudest moments. We're going to need a little bit of heat. And be really careful when pulling this off. Fortunately, I have my iPhone here and I don't have a proper tripod or anything, so let's see what we can do. Yeah, there's screws on the other side. So we'll undo those. Pull this cover off. And there we go. I believe I need to bump it on its back. There we go. We're going to be real careful on this one. I don't have another one. These displays working in NOT, they're very expensive. So, yeah, a little bit too expensive if you ask me. But they're also getting hard to find. Okay, so we got these off. Here's how I did it. I used the flux to help, distribute the heat more evenly. I got one side of the capacitor hot, melted the solder, and then I gently rocked the capacitor back a little bit, and then I did it to the other side and rocked it back a little bit. Then did it this way I don't rip the pads off, and I avoid excessive heat exposure through desoldering with wick, which doesn't always work as you'd like it to. Okay, we're going to do one of these bigger ones so you can see it better. I'm going to apply my flux on either side. I've got my iron cranked up to about a little bit too hot, about 650 degrees Fahrenheit. I'm going to give it some time to melt, start lifting. There's a little more flux on that one. Work on the other side. You don't want to be too forceful. You rip the pads right off the board. Got this pads lifting off. Be gentle. There we go. And that is the right way to do it wrong. That was the 22 or the 100? That was the 22 microfarad. And 22, 35 volt. Yeah, so I got plenty of those here. I'm not going to clean the pads off. I'm going to reuse the solder that was there. But what I'm going to do is I'm going to tin the leads on the new caps a little bit. Okay, I'll get this out of the packaging. I've only got 62 thousandths solder, so I'm going to get it on my tip. And just kind of brush it on to each lead. There you go. I'm going to get some flux. Tack it on each side. And that's how you do it. Okay, we're practically done here. Come on now. There we go. We got all of these at 6, 9, 11 caps. I got a little bit of flux on the screen, which I removed with 90% alcohol and a microfiber cloth. Now there's little hairs left on the screen. Now this is the side that faces the backlight, so we want this to be as clean as possible. I'm going to be using this silicone roller, which is an official Apple part. This is from the service kit for the iMac. And we're going to use that silicone roller to remove any hairs left over by the microfiber cloth and any dust and other things. Not sure if Apple still sells this because the new ones are no longer field serviceable. The screens and the front glass are sold as one unit. You see I got a little smudge there, so I'm going to take my microfiber cloth and I'm going to wipe that smudge off. The other side doesn't matter. That's the side that faces the user. Okay. I think you can buy these rollers though separately. I think they're useful for other things. And then it has a sticky pad for cleaning. So that's as clean as we're going to get it. Anything that shows up here, anything that's left on the screen will show up when we fire this thing up, and we don't want that. So here's our backlight assembly. We're going to reassemble this. We just drop it back in. I'm going to give this a quick spray with air and clean it up a little bit. Make sure there's no dust that fell on there, and we'll hope for the best. Okay, so now these are all the caps we took off. None of them appeared to be leaking, though. I will say that. I will disclose that none of them appeared to be showing any signs of leakage, but it's only a matter of time, you know what I mean? So put this on. Alright, wish me luck. Okay, so we've assembled the clamshell. I've just connected the video cable. Let's see what happens. I'm nervous. I really am nervous. I think this is going to fail. That's not a very good soldering job. I'm not very good at surface mount, but hey, here we go. Did I not plug in the... Oh, I didn't plug in the power. Yeah, make me nervous like that, right? Here we go. Okay, we have backlight. Oh, that's not good. Oh, wait. It's, oh my god, it works. Look at that. Holy shit. It worked. Look at that display. Oh my god. Look at that. We have even perfect contrast between the bottom and lower halves. It's so good you can't even see the dividing line. Oh my god. So we still have, alright, so I guess that's normal. Get the contrast just right. It looks really good. It looks really good. This is how they look though. And the backlight looks good. I don't see any after effects or anything. It looks pretty clean. If nothing else, at least it'll be stable. In other words, you know, for the next maybe 5 to 10 years, it should last, and then maybe the cap job will need to be done again. Let's bring the contrast all the way to the... Yeah, that looks pretty good. So to do the CMOS battery in this sucker, we're going to need a CMOS battery. Now, these don't use just any battery. They use a rechargeable nickel metal hydride coin cell. And here's the one I bought from, I believe I got this from Mauser. And here's the part number, if you need one. P083ND. That's what you need. The VL2320HFN. And out of the package. They don't come cheap, but it's the only battery that's really meant to work in this device. So what this is going to do is allow the CMOS or system settings, like for example, the power management settings, the clock, date and time, that stuff will be preserved. We're going to keep that. We're going to reuse that. And we've got to pull this board out. So we've got to remove the inverter, the backlight inverter board. And we're going to need our Torx driver. I did this to my PowerBook 170, and it's been about 10 years since that was. I mean, I've had that 170 for 10 years. It's unbelievable. But it was done 10 years ago, and now it's due for another one. It's about as long as they go. Actually, you know, I haven't really tried it, to be honest. Disconnect the keyboard. I'm going to use a black stick for that. And we're going to disconnect the display connector. There, a black stick. Come on now. Oh, it's down there, isn't it? No. I'll use a fingernail instead. Oopsies. Come on. I can get to it better from here. There we go. Disconnect the keyboard. This is the interconnect board, and for whatever reason it also holds the... It's like this is whatever they couldn't fit on the motherboard. It goes on here. Microphone, speaker. You know, just stuff that they couldn't find a home for otherwise. And it should be pretty much liberated by now. So let me put the camera down and we'll do this the right way. In terms of skill level, this one's pretty easy. You've got basically 2 solder joints to undo. This one here and this one over here. So pretty easy to do. Okay, so we've got that battery replaced. Now there is an insulator below the battery that we had to peel off of the old one and put that on the new battery. I want to point out that this one was leaking. See, there's some rust or something around the battery. So this one was a disaster waiting to happen, and crisis averted. So let's put this insulator on this one, and we're done. Now we're going to put this board back in. Say let it charge for a little while. Now, real important, when you reinstall the inverter board, that you ensure that the sliders line up. I recommend pointing them all into the same direction all the way. And that way you're more likely to get it locked in correctly the first time. Here we go. So there is a trouble spot here. This support tower is cracked. I'm sure you can see it, but it's right there. Now that crack is only going to get worse. There's also one on this side, although not as severe. Very, very faint hairline crack. But it just so happens that the replacement part, or the one that I just got, is also cracked, but not as seriously. I'm contemplating swapping out this entire upper pan with the other one. But I think what I'm going to do, I'm going to save it at least in case I do need it eventually. It is in good shape. I didn't see any issues with it at all. Let's see here. Yeah, it's in pretty good shape. So I'm going to hang on to it in case I do need it in the future, but of course I'm not throwing away any parts this time around. I'm saving everything. Everything gets saved. I think what I'm going to do is actually put some grease, some of the right stuff. I'm going to put some grease in these feet so they move a little smoother. Okay, so now I've applied a little bit, just a sparing amount of this. This is actually, this is not the M-Coat stuff that I use at home. This is designed for HP LaserJet plastic gear assemblies, but you can see nice smooth action versus, actually this one's not so bad. Yeah, this one's not so great either. There we go. Yeah, so that's what you want. We're going to have to do the other side now. Looks like somebody may have greased it at one point. Oh no, that's just, I don't know what that is. Let's get that off. There we go. Yeah, there would have been some kind of a lubricant at one point, and it's now gone. So we'll just apply a little bit of this stuff. Not a lot, just a little bit. I don't want to go crazy with that shit. So then we're going to put that in there. Ooh, wait a minute. Is that cracked? No. It almost looked like it was. Screw it back in. I apologize for the filming on this one because I'm using my iPhone to do this. You don't usually bring my real camera anywhere. And I'm at work, it's at the end of the day, and whatever. One of these days I'll get a better camera that I can... Oh, that's much better. Okay. Little things you want to do while you've got it apart. Little fixes, and I mean, this is a machine that will only increase in value as these become more collectible. And I'm gonna put some epoxy on these. Just gonna drape them and drizzle them in epoxy, self-mixing epoxy, and that will give it hopefully some additional support. I'm not expecting miracles here, but yeah, if I could only sleeve it, but I can't sleeve it with shrink tube. Another way I would fix that is I would take some shrink tube, put some epoxy around it. Before it cures, shrink some plastic around it, and that would stiffen it up. What I'm going to do is I'm going to drizzle some self-mixing epoxy on there, and that'll hopefully give it some additional support. I don't expect it to really help. I mean, let's be honest, these machines are no longer being used in the field. You know, the ones that are left, like this one, it's just going to sit on a static display forever, and it's not going to be subject to the stresses of use that it would have been subject to, you know, back when it was considered relevant. Now that it's an antique, in every sense of the word, you know, I don't expect it to need to stand up to the rigors of a beast. But one thing that I like about this particular unit is that the base pan has no damage. Oh, a little bit there, a little bit there. I guess I spoke too soon. But this is in the best shape I've ever seen one, so that does say a lot for it. It really does. What never ceases to blow my mind is how much stress damage these particular standoffs usually exhibit. And it got me thinking, I mean, they're not under much stress, if any at all. They're just holding the drive sled cover back in place. I think what's really happening here is the ABS plastic is actually shrinking and causing its own stress cracks. And that's what I'm thinking. But this is a very troubled area on these as well. And this one seems to be suffering more than most. But I was able to epoxy around all of them for additional support. Not sure how well it's going to work. They're not sheared off yet, so I'm hoping that it works out. I mean, who knows? It could work out. It could... I mean, I don't think it really matters at this point in this device's life. Again, it's going to be more of a static display than anything. At least it's all there, and that's what really matters the most to me. This is our video board. So if you've got one of these old classic PowerBooks, especially the 165, and you've got video issues, take a look at that board right there. Actually, that's also the processor board, if I'm not mistaken. So, and this is our modem. This is a factory option. And this one happens to be equipped with. So, those screws back in. And you can see how the epoxy drizzled onto and allowed to pool around will help provide, hopefully, in theory, a little bit of structural rigidity to these failing towers. At this point, apparently dried. This point, it is solidifying quite nicely. I'm going to give it another hour or so before I do any final assembly. And that ought to do it. So I've got the bottom screws in place. Real important, this screw right here, do not over tighten this screw. That screw is it's countersunk, and if you tighten it too far, it'll actually split and crack the plastic right there. The other thing is, if you have an original battery, go ahead and put tape over the contacts. If the battery is blowing up, you're going to want to disassemble the pack and remove the cells. But these batteries, at this point in time, I haven't found a single one that doesn't cause the machine to fail to power on or some other weird problem. So we're now ready to fire it up as an assembled unit for the first time in about 6 months now. It's really been that long. Unbelievable. I don't have the rear door. At one time I had a spare door, and I don't have that right now, so I'm going to fire this baby up. Oh, I forgot. I still have these. Now, these little rubber grommets, they're in pretty rough shape. Over time, they begin to either solidify or turn to mush, one or the other. And those are kind of in between. So, let's see. Power hooked up. Here we go. Alright. Now I've got my, my contrast way out. There we go. Yeah, that's working nice. Look at that. So nice, so smooth. Yeah, these passive matrix displays, even when they were brand new, they were quite horrible. And, you know, you're just not going to get a good image out of them. Ever. You never will, never would, never could. That's about as good as you can expect. Now, the backdrop setting, I believe, is stored in CMOS or PRAM. And I also, if I fix this trackball too, I actually use my method of gluing the silicone rollers in place so they don't move around back and forth in the shafts. I'll show you what I mean. So I pull this out, get them all out of here. What I do is these little blue silicone rollers, sometimes they're black, sometimes they're blue. What I do is I slide them over with a black stick and I put a drop of super glue, just a tiny drop on the shaft after cleaning it with alcohol, slide it back, and it keeps it in place. Because as they get older, they begin to slide around, and that's why these trackballs often don't work very well. Something I've found over the years working on these things. I probably own more of these PowerBooks than many collectors. I'm not saying I have owned the most. I've owned quite a few of them over the years. The brightness control panel is on here for some reason. Yeah, see, it's not compatible. Also, mouse control settings, trackball speed is stored. That's why you want to make sure that battery is functional and replaced with a new one. Let's take a look at our backdrop here. I like the, which one is it? This one here. Yeah, there we go. That gives you a better picture of what this display can and cannot do. But it's holding its own. There we go. Now this thing has no software on it to my knowledge. The gentleman I got it from, I believe, just put a base operating system, and it looks like 10 or 7.1. Yeah, it is 7.1. So I'm going to do a fresh OS reload on it and put my own software on here, and I'm going to call it a done project. So thank you all for watching, and I appreciate your support. I don't know if you guys can hear it. This hard drive is not sounding healthy. It sounds pretty pitiful. It's got 4 megs of RAM. That's what I wanted to do. I wanted to see how much RAM was in it. 4 megs, and I didn't look when I had this open before. But this drive is, it's not sounding so nice. I wonder if the floppy drive still works. Let's check that out. I do have one good 2.5-inch drive left at home. SCSI. This may be the one that I put it in. Uh-oh. Floppy drive's not responding. So it's probably got a bad floppy drive. That's a shame. It's not doing anything. That's too bad. Let's give it a reset. Yeah, that sucks. Sounds like the floppy drive may be bad. Well, it's doing something. Okay, well that's a step in the right direction. At least it ejects and it does acknowledge that there's a disk in there. Let's see what happens. Try it again. Okay. There we go. I just had to wake it up, so to speak. See if it formats. That drive does kind of sound like a sick cow. I wonder if letting it run for a little while might be the cure for it. Sometimes it works, sometimes it doesn't. Sometimes they get better, sometimes they don't. It's in pretty good shape though, otherwise. Aside from all the obvious problems. Contrast down just a tad. Okay. It's not dead. No, it looks like it's working fine. Damn, they built these things pretty well, I guess. Not bad, not bad. What time is it? Oh wow, it's an hour later than I thought it was. Alright. Looks like it formatted, and there we go. One formatted diskette coming up. Eject it. Not bad. Back in. Yep, working fine. Sweet. You guys are probably wondering why these early PowerBooks had two buttons, one on the top, one on the bottom for the trackball. Well, that's not for any reasons other than, it's not for any good reason. It's because when you're typing, this becomes your default click button, and when you're just kind of scrolling around documents, you can use this button here. That's all it is. It's not left and right click or anything crazy like that. They both do the same thing. Yeah, I might pop in the, I've got an old PowerBook Duo kicking around that's got a good drive in it. A pretty nice drive in it, in fact. And I might be putting that into this one. So, alright guys. That's going to do it for now. Thank you for watching.